Hello, everyone. Thank you for joining us today. For those of you who haven't attended one of our previous webinars, my name is Jana, and I am an alarm management consultant with ProcessVue, working on alarm management solutions, implementations, and more recently, some of our AI initiatives. If you have joined us for some of our other webinars, we've talked quite a bit about AI in alarm management, what it means and how it fits into OT. Well, today I want to take that conversation a step further. Instead of just talking about AI as a buzzword, I want to talk about how the recent release of the ProcessVue Gateway is fundamentally changing the way we interact with alarm management systems. We'll discuss where the industry has been, where it is today, and where we believe it's going next. We'll also be doing a live demo later in the session, so if you have any questions, please submit those in the chat or via email to info@processvue.com. We have already received a few questions, and we thank you for those. We will follow up in response to those in a couple of weeks with the Q&A sheet. Now, for those of you who don't know, I am based out of Houston, and I've lived here most of my life. And if you're from Houston, Texas, you would be aware that hurricane season is just around the corner. After living through your first hurricane, you learn very quickly that surviving hurricanes isn't about reacting after the storm hits. It's about preparation, prediction, and understanding risk before impact occurs. When a hurricane forms in the Gulf, nobody waits until landfall to start acting. Days before impact, meteorologists begin tracking storm paths, emergency teams prepare response plans, the refineries and chemical plants in the area evaluate shutdown risks, utilities stage repair crews, and families buy supplies and make evacuation plans. And all of this happens with uncertainty, because the forecast is never perfect, but predictive tools allow us to prepare days to weeks in advance, which ultimately reduces risk and improves the outcome. But there was a time before technology when people weren't as fortunate, and this is difficult for me to even fathom because what do you mean there was a time before weather radars and models and even communication systems? But prior to that technology, people had to simply observe and react to storms as they were happening. Well, thankfully, weather forecasting eventually evolved to tracking storms in real time with radar, and to now using massive predictive models and simulations. That evolution has completely changed how society responds to severe weather. Now, I realize this may seem like a strange direction for an alarm management webinar, but what if we applied that same mindset to industrial operations? What if alarm management wasn't just about reviewing alarm floods after they occurred? What if we could identify early warning indicators, recognize developing operational instability, and guide operators toward areas of increasing risk before a flood or upset occurs? Because today, most alarm management systems are not that evolved. We collect our alarms, we analyze KPIs, we generate reports, and then we react afterward. That's valuable, but it's similar to weather forecasting in the early 1900s. We knew storms existed, but we lacked the tools to truly interact with and anticipate them. At ProcessVue, we've had a front row seat to the evolution of alarm management for more than 30 years. Our journey reflects how the industry itself has evolved. First came Sequence and Analyzer, which focuses on alarm and event collection, KPI analysis, reporting, and visibility into alarm system performance. And then came Guardian, which is a master alarm database and management of change platform that brings governance, documentation, rationalization tracking, and lifecycle management into the process. And now, most recently, we introduced the AI Gateway. And the AI Gateway allows large language models to interact with systems like Analyzer and Guardian using MCPs, or Model Context Protocol, to create a much more interactive experience with operational data. When we step back and look at both weather forecasting and alarm management, we can break the evolution into three major phases. The first is reactive. Something happens, then we analyze it afterward. We are waiting for the storm. The second is interactive. Here we gain visibility in near real time, we can ask questions, and we can investigate patterns dynamically. We're understanding the storm faster. And finally, proactive. Systems begin helping predict risk, guide attention, and support decision-making before major impacts occur. So we recognize the storm is coming before it makes landfall, and we prepare. If we're honest, most of the industry today is still operating primarily in the reactive phase. And that's not necessarily because the industry lacks data. In fact, most facilities are drowning in data. The challenge is turning that data into usable operational intelligence. In the reactive phase, operators experience alarm floods, engineers investigate afterward, reports are generated, and corrective action happens later. Problem is that operational upsets develop long before alarm floods occur. Patterns emerge, signals drift, equipment behavior changes, the operator workload increases gradually, and traditional alarm reporting platforms such as Analyzer provide value by helping organizations identify alarm floods, track standing alarms, measure KPI performance, identify bad actors, and benchmark against standards. Well, this is key insight, but fundamentally, the workflow is still the event first, analysis second. It's similar to old storm tracking. A storm hits, then we study the damage. Reactive systems often struggle to connect all of those signals fast enough to meaningfully assist operators in real time. And this is where the industry starts transitioning into something new. Just like weather forecasting evolved from post-storm analysis to live radar systems, alarm management is beginning to evolve into a more interactive model. And this is exactly where the ProcessVue AI gateway fits. The interactive phase changes how humans interact with operational data. Instead of requiring engineers to manually build SQL queries, navigate multiple systems, generate reports, and interpret raw datasets, users can interact conversationally with operational information in real time to gain a better understanding of events and upsets as they occur. It's very similar to how radar transformed weather forecasting. Radar didn't predict every storm perfectly, but it gave meteorologists visibility into the developing conditions in real time. The AI Gateway does something similar for alarm management. The AI Gateway enables large language models to interact with operational alarm management systems using MCPs. An MCP server is a translator between data sources and AI. It lets AI understand, access, and use real systems in a safe, standard way through governed APIs, unlocking intelligence without compromising safety, compliance, or operator confidence. AI models are powerful, but they depend on clean, trusted inputs. Bad sensor data or poor signal quality leads to bad predictions. They also need clear context, like operating mode, production goals, and process relationships to know whether a recommendation actually makes sense. In practical terms, that means an engineer or an operator can ask questions like, what caused this alarm flood? Which areas have the highest operator workload? Show me my nuisance alarms from the last 30 days. Instead of manually digging through historians, reports, configuration databases, and spreadsheets, the AI Gateway enables the system to retrieve, correlate, and present that information interactively using data from Analyzer and Guardian. The real value here isn't just faster reporting, it's context. Historically, operational knowledge has been fragmented. You have alarm history in one system, rationalization records somewhere else, management of change data elsewhere, and expert knowledge living inside people's heads. The AI Gateway begins connecting those worlds together. And once systems become interactive, they become the foundation for something much bigger. In the last couple of webinars, I've demonstrated how the AI Gateway creates this interactive alarm management experience using LLMs. In my last webinar, I used Claude to help analyze, interpret, and make decisions using actual alarm management data from our Analyzer and Guardian systems. I asked it to create things like shift handover reports, operator response guides, and alarm reduction recommendations, all of which were done in a matter of minutes with greater intelligence and the context of my alarms and their configuration to help steer the responses. This is the shift that ProcessVue is creating from alarm management to alarm intelligence. And in an industrial landscape, this advantage could be the difference between having the competitive advantage. We're not stopping there. We don't believe interactive systems are the final destination. We believe the ProcessVue Gateway is the foundation to so much more. Today, most alarm systems tell operators what already happened, but in the future, we envision systems that help identify developing instability, abnormal operational patterns, increasing upset risks, and areas requiring operator attention before escalation occurs. At this point, rather than continue talking theoretically, I want to show you what we think this might look like in practice. So here's a sneak peek of a prototype that we've been working on that demonstrates the power of the AI Gateway. The idea is a unified operational intelligence layer across the ProcessVue ecosystem. So if I pull up this web interface, I can see this unified single system, and we can go and create a canvas. So the idea is that we are tying the analyzer and Guardian data into a single interface with the ability to integrate AI and create this customizable user experience. So if I go to create a new canvas, I can type webinar, and it's going to populate some suggested starter layouts with some suggested widgets. So say I just want to look at my KPIs and do a quick overview, I could click this and it will populate with some widgets. I could do a full analysis, compliance focus, or I can create a canvas completely customizable to myself and my needs and drag and drop widgets to get the analysis that is tailored to my exact needs. I'm going to do a full analysis because it has 12 of the 13 widgets. So I'll select that, and it creates this and drops all of my widgets on here. You can see at the top, I can choose the period of alarms that I want to look at. So whether that's 1 hour, 24 hours, 30 days, or you can create a custom date filter, as well as there's a shift calendar. So you could create shifts and analyze alarms in the context of a shift. So I'm going to choose 30 days and refresh that. And then we could go over here. This is a simulator system, so our data is broken up into different industries or verticals, but yours, you might be looking at different areas of the plant or however you choose to organize your data. First, we see our KPI widget. And so up here, this has some of our key metrics for alarm management. So your average rate of alarms, max rate, percent of time in flood, standing, active. So all of our key widgets or key metrics up here. Then if I scroll down, there's an ISA 18.2 compliance summary. So it lists all of my metrics and then compares them to the ISA standard or target and tells me where I fall as far as being compliant with those standards, whether I'm on target, outside the target, or near the limit. And then over on this side, we have an alarm rate analysis that gives me some of my key metrics regarding or surrounding my alarm rate. So my average rate, peak rate, the flood conditions, and then if I had greater than or equal to 36 alarms per hour, it would be considered a heavy hour, and it would tell me the percentage of heavy hours that I have. Scrolling down, we see a priority distribution. So this is all of my alarms broken down into priority, so I can see how many P1s I have and then the contribution of that to my total alarms. So I have a high P1 count, which is not recommended. And then over here, my top 10 alarm frequency. Now I could do top 10, top 3, 5, something custom, but it's going to display my top 10 alarms in a graph and then sort of classify those as the behavior that they demonstrate. So this one is chattering and stale. I can have a fleeting alarm and it highlights the count and then again the contribution of that alarm to the overall total alarm count. This is similar information, just organized differently. And then down here is my active alarms. Again, this is a simulated system, so bear that in mind, but I don't have any active alarms on my data center, so I'm going to switch to my oil and gas. And here I can see my list of active alarms, which has the date, time, description, status, priority, plant area, all of the relevant alarm information. And as I scroll down, we get to more widgets. So stale alarms, chattering alarms, fleeting alarms, all of that information is displayed in their own widgets. There's shelved, counts, inhibited, overridden. Down here is a flood analysis. So it tells me all of my flood events that occurred in this period of time. And then it is a breakdown of the priority of alarms that occurred during that flood event, as well as I think I had 13 alarms in 10 minutes and my longest event was 10 minutes. And then over here we have some operator response information. And yeah, that is most of our widgets. So all of this data is being pulled from Analyzer, again, using this gateway. So we would see similar information in Analyzer and some of the reports and dashboards, but using the gateway, we have the ability to pull this information and then sort of combine it with the Guardian information. So one way of doing that is I could go and edit this canvas and add some Guardian widgets. So these are all of my analyzer widgets, which we just went through. And again, those are using the MCPs or API tools to pull that information. And then I have rationalization widgets. So this is going to be more of my Guardian information. So I could have an audit trail, master alarm database explorer, Guardian config, and I have the ability to drag and drop that onto my canvas. I could go through and delete widgets, so it's fully customizable. Another way to integrate Guardian is, say you have an operator who has created his own canvas and he has a couple of widgets, but his primary concern is seeing those alarms, those active alarms as they come in. And so this is going to be your alarm record from Analyzer, but say the operator, this alarm comes in and the operator isn't quite sure how to respond to it. The benefit of having all of this information in a unified layer is that instead of having to go to Guardian and say, or look up the response to this alarm in the alarm response manual, he can just click on this alarm and it's going to go fetch that alarm or alarm response manual data from Guardian. Looks like, let me choose an analog tag. Okay, so here this is an analog tag, so it has multiple alarm statuses. It came in as a deviation, so the operator would know this is the consequence of missing. It would likely result in unstable operation and quality and recovery losses. And then this is the operator action. So this is the action he should take to hopefully resolve the alarm. And then if you continue to scroll down, it lists those other statuses for that particular tag. And we see in this case for the high, it's actually intelligent enough to pick up and flag that the DCS says that this is a priority 2, but the rationalized master alarm database suggests that it should be a priority 1. So that is flagged. And that's because both of those, or that data is available within Guardian. So all of this is data that is being unified using the gateway. So I haven't integrated AI at all. None of this is going to the cloud. This is just strictly Analyzer and Guardian data. But the real value of this, I think, comes in when you integrate the AI element. So if I come over here and look at one of these pre-configured canvases, and let's refresh, make sure the data is up to date. So I see similar widgets. One that I didn't show previously is this heat map. So I can see the areas of my plant that are experiencing higher alarm activity. But back to the AI integration, if we take a look at this top 10 alarm frequency, if I click on this button right here, it's going to do an AI analysis. So it's going to now loop in the AI and integrate the LLM to provide key insight regarding those top 10 alarms. So if you were here for some of the previous webinars, in the last one, I was using the AI gateway to interact with my system through Claude. So I had a Claude window pulled up and I was asking, what are my top 10 alarms? And then it pulled the top 10 alarms from the analyzer system and then sort of interpreted that data, gave me some insight, recommendations. Well, this is a similar activity, I guess, if you will. This would be similar to prompting Claude to do the same thing, but in this case, it's available at the click of a button. So again, I'm not going through to Analyzer and Guardian and having to navigate through all of these different windows. It's one unified interface. So I can do an AI analysis. It comes back with an executive summary of that top 10 alarm information, an overview, and then it does a bad actor analysis. So it recognizes my bad actors. It tells me whether they're chattering, fleeting, and then it proposes this hypothesis of the possible root cause and an impact. And then it goes through more of my bad actors and does the same analysis. And then it does an ISA 18.2 assessment to tell me again where I stack up against the standards. And then finally it concludes with some recommendations of how these bad actors can be addressed or things that can be done to, like in this case, estimated impact. This activity could eliminate 3.1% of total alarm volume and remove one stale alarm from the backlog. So it's that kind of insight, which again is sort of the benefit of adding this AI integration. Now, this is still mostly interactive. So we're still kind of in the interactive phase where we're interacting in real time and understanding our alarms faster. But I said that I think, or we see alarm management moving to more of this proactive approach or phase. So if I click on this, the canvas is update. Okay, the canvas not only does it house the widgets that have the analyzer and guardian data, but it can also be sort of a canvas or house for the agents. So we came up with a bad actors agent. And so the idea here is that I could set it to run 24 hours, whatever period I want. And then as long as my system is running, I could step away and my agent is going to go through, pull the data from analyzer, analyze those alarms, and then pull out and flag the bad actors. And then it's going through, putting the tag or the alarm, and then categorizing it, whether it's stale or frequent, and then the count of that alarm and a recommendation. So the recommendation, investigate duplicate alarm configuration, resolve root cause of standing condition. So all it says, this is sort of what we recommend, and then it adds it to an analyzer, the analyzer work list. So it's closing the loop and addressing the human in the loop. So while this is happening without the human being involved, it's pushing it back to analyzer so that the human can get involved, check what's being recommended, and then make the changes accordingly. In this case, in the second one, it says that we should audit the P1 or P3 alarm set point configuration for this tag and rationalize priority assignments per ISA 18.2. So this one requires more of a rationalization effort to the actual tag configuration or changes to the tag configuration. So it adds it to an analyzer work list as well as pushing it over to that rationalization agent. So over here is the rationalization agent, which is set up similarly to run every 24 hours. And we can see that it has dropped this alarm over here. And so it provides more information about the recommendation for resolving or rationalizing this alarm, and then it adds it to a guardian work list. And so this is when we start to see that shift to a proactive system. So while the human is still in the loop, the alarm system is doing this on its own, and it's kind of helping to take care of itself, if you will. So it's helping flag things before the operational upset so that you can respond proactively rather than reactively. And so here in Houston, we don't wait for a hurricane to make landfall before we act. We track it early. We use historical patterns, real-time radar, and predictive models to understand what's coming, and we prepare. Imagine a system saying, this unit is beginning to show characteristics similar to previous upset conditions, or operator workload in this area is increasing rapidly. It is recommended that you focus attention here. This could involve predictive analytics, AI agents, contextual reasoning, operational pattern recognition, and continuously learning models. So we're not replacing operators, not removing engineers, but helping them focus attention where it matters most. That way we can recognize and prepare for operational storms before they make landfall. That's the future of alarm management. If you'd like more information on ProcessVue or the AI Gateway, you can visit our website, or you can also find us on LinkedIn and YouTube. As a follow-up, we will make this webinar available as an on-demand resource in case any colleagues couldn't make it today. We hope you enjoyed our webinar. Thank you for your time today.